All right, take a look around you. I mean, right now. The world is pretty much built from a bunch of simple shapes, right? That box on your doorstep, the can in your fridge. But have you ever really stopped to think about how much they hold, or how much material it took to actually make them? Well, today we're going to unlock the secrets of our 3D world by digging into volume and surface area.
You know, these aren't just some abstract math problems. Figuring this stuff out really just comes down to two simple but super powerful ideas: what's on the inside of an object and what's on the outside. Once you master that difference, you'll have the tools you need to measure just about anything.
So first things first, let's get our toolkit ready. Before we can start measuring any shape, we have to be super clear on what it is we're measuring. And it all boils down to three key ideas: volume, surface area, and capacity. Let's kick things off with volume. Now, the official definition is the space occupied by a body. But honestly, a much easier way to think about it is this. It's all the stuff that can fit inside an object. You know, how much water is in that bottle? That's its volume. Simple as that.
Okay, so what about the outside? Well, that's where surface area comes in. If volume is the stuff inside, you can think of surface area as the skin on the outside. It's the total area you'd need to paint or to wrap. It's literally the sum of the areas of all the different faces of a solid object.
So, here's the absolute biggest difference, the thing you have to remember. Volume measures the three-dimensional space inside an object, which is why we use cubic units, like centimeters cubed. Surface area, on the other hand, measures the two-dimensional space on the outside, so we use square units. That's the key right there. Inside versus outside, cubes versus squares.
All right, let's put this into practice with our very first shape. We're going to start with the simplest, most perfect 3D shape there is, the cube. What makes the cube so great is its perfect symmetry. I mean, its defining feature is that every single edge is the exact same length. Its length, its breadth, and its heights are all totally equal. For simplicity, we'll just call that measurement A. And because it's so perfect, the formulas are beautifully simple. To find the volume, the space inside, we just multiply length times breadth times height, which, for a cube, is just A times A times A, or A cubed. And for the surface area, well, we find the area of one of its square faces, which is A squared, and since a cube has 6 identical faces, we just multiply that by 6. Easy.
So, you ready to put this new toolkit to the test? Let's try a quick problem. If I tell you that the total surface area of a cube is 294 square centimeters, can you figure out its volume?
And the answer is 343 cubic centimeters. So how in the world do we get that? Well, we just have to work backward. We know the total surface area, 294, is for all 6 faces combined. So to find the area of just one of those faces, we divide 294 by 6, and that gives us 49. Okay, so if the area of one square face is 49, its edge length A must be the square root of that, which is 7. Now that we know the edge is 7, the volume is just 7 cubed, which is 343. See? Not so bad.
All right, now that we've got the cube down, let's move on to its much more common real-world cousin, the cuboid.
So unlike a perfect cube, a cuboid, you might also hear it called a rectangular solid, has a different length, breadth, and height. And this shape is absolutely everywhere. It's your phone, it's a book, it's a brick. It is probably one of the most common shapes you'll ever run into.
Now the formulas are a little step up, but the logic is exactly the same. Volume is still just length times breadth times height. For surface area, we just have to remember that there are 3 pairs of identical faces. You've got the front and back, the top and bottom, and the 2 sides. The formula simply calculates the area of each of those 3 unique faces, adds them up, and then multiplies the whole thing by 2.
Okay, time for a little puzzle that combines what we've learned. Imagine you have a big rectangular block. You melt it all down, and then you use that material to make a bunch of tiny little cubes. The question is, how many of those tiny cubes can you make? This is all about volume.
Now this might sound kind of complicated, but the path to the answer is actually super logical. First, we'll calculate the total volume of that big old cuboid. Then, we find the volume of just one of the tiny cubes. And finally, we just divide the big volume by the small one to see how many times it fits inside. And check this out. First, the volume of the large solid, that's 50 times 64 times 72, is a massive 230,400 cubic centimeters. Next, the volume of one little cube with a 4 centimeter edge is 4 cubed, or 64 cubic centimeters. So when we divide the large volume by the small one, we find out you can make exactly 3,600 of those small cubes. Pretty cool, right?
So far, we've handled shapes with straight edges. Now let's throw some curves into the mix and tackle the cylinder.
A cylinder is basically just a circle that's been stretched out. It's got a circular top, a circular bottom, and a curved side. You see them everywhere: soda cans, pipes, candles. And all you need to measure one is its radius, which we'll call r, and its height, h.
So here's the toolkit for our cylinder. The volume is actually pretty intuitive. You just find the area of the circular base, that's pi r squared, and then multiply it by the cylinder's height. Now, the surface area formula might look a little tricky, but it's really just 3 parts added together: the area of the top circle, the area of the bottom circle, and the area of that curved side if you were to unroll it flat like a rectangle.
Okay, we have the theory, we have the formulas. Now let's see how this all comes together in a really practical, real-world situation.
Imagine this. You need to paint a room. Here are the facts. You know the room's dimensions, but you also have doors and windows that obviously you are not going to paint. And you know the cost for square meter. The big question is, what's the total cost going to be?
So here's our game plan. This is a pure surface area problem. We'll start by finding the total area of the 4 walls and the ceiling. Then we'll find the area of the doors and windows that we get to skip. We'll subtract the area we won't paint from the total area, and finally we multiply that final number by the cost. Let's do it.
After running all those numbers, the total cost comes out to 748 rupees and 80 paise. By calculating the total area of the walls and ceiling, then taking away the area of the doors and windows, we found out the final paintable surface was 124.8 square meters. And at 8 rupees per square meter, we get our practical, real-world answer. So there you have it. You've officially got the toolkit for cubes, cuboids, and cylinders. Now you can see the world not just as objects, but as measurable spaces. The real question is, what are you going to do with that power? Look around you. Your world is full of these little puzzles, just waiting to be measured. Thanks for diving in with me.